Welcome back everyone. In this series of video, Form 5, I'm going to show you on Form 5 Physics Chapter 1, Wave. Just like my many others videos, all my videos here is intended to help you out on the objective and understanding of the question. Question. You need to really read through your reference and textbooks for the theory behind it. This video helps you to understand those theory. Right now, to start out with today's session on wave. So, what is actually wave? Wave is actually a product. Okay, product caused by a point or body that moves around a center point back and forth. Okay, so I'm going to show you one example where this is a spring unit, and then I have an object. This is actually a side wheel object with a hole onto it. I'm going to show you why I need a hole. There's a solid object, hole on it, and then what happened, I'm going to attach another spring down here, attached to a solid body. The reason I need to have two springs because when I oscillate it, what happened, it will single out the friction. Okay, so that my movement, you get a continuous movement, and it will last longer. So what happened now, I'm going to give you some definition. When it's at equilibrium, meaning when it's not moving. Okay, so this is equilibrium. I physically draw a virtual line. It's an equilibrium line. Now what happened when I were to pull downwards and release, what happened, you find that this object obviously would oscillate. Will go down, up, down, up, down, up, down, up, down, and up. And because of that, it creates a wave. Okay, then how do you see it? Because you can't see it. The movement is called oscillation. Okay, the oscillation of this object would produce a wave. Oscillation is like vibration. Okay, but oscillation is more systematic. Okay, oscillation is actually a point. Let's say at this point, you may make a quick note from here, then it helps you out with the reading. Or a body. This is a body that moves back and forth, along a line, about the central of equilibrium, Okay, and it produces a wave, and hence produce a wave. Okay, so this is actually what happened. It's a point, a body, move back and forth along a line of equilibrium and produce a wave. Now, in your book or reference, it says there's no mass transfer kind of thing. What does it mean by that, right? It says you can't see it here. So what I'm going to do in the next illustration, I think you may pause this video if you want to copy down this or not. Well, I was thinking to erase this. Or from this diagram, what happened now is I'm going to trace the wave. How I'm going to trace wave from here is like this. I'm going to erase this. What happened now is, instead of this system, now I'm going to place a roll of paper roll. Okay, one roll of paper, paper, roll it out over. Okay, and then what happened? I'm going to attach a pen or spray a pen through it. I mean, into the paper, into this body, a pen or pencil, pointing towards the paper, and then only I start the oscillation. Then I start the oscillation up and down. At the same time, I am going to pull this paper. I want to pull this paper to the right. I pull it to the right while this thing is oscillating. So what happened? This pen is not going to. This pen is going up and down movement, while this paper is going from left to right. This pen does not go to the right, but this pen go up and down. What happened at the end of the experiment? You get to see. I mean, I'm not going to draw the paper in green, so straight away what you see from this piece of paper later on would be you have something look like this. Okay, and you may add in some axis to it. You from the top, bottom, divide by half, and then you may draw a line. This is where the equilibrium. This is where the point when it's at rest. Here. This is the point at rest. Okay, and then stop. Then you may draw vertical line where this would be your y-axis, and this one you may be your time axis. Okay, this is called amplitude. How far is it from equilibrium? This is 0, etc. Now, so this is what we call the wave. You trace the wave from the oscillation. Okay, so in this chapter, I want to start it easy so that you can help it out in your reading. They name the one on top, the one here, up here, as crest. The one on top is called crest. The one down here, the point, the minimum point here, is called trough. GH, trough. Okay, crest and trough. Now, at the same time, what you need to learn is you need to know actually for this chapter to be specific. You have something called wavelength. Okay, wavelength. Wavelength symbol lambda. Pronounce lambda. Lambda. Okay, what is it? How do you measure? It's a distance from either crest, this point, to this point. In terms of length, how far are they apart? The crest to crest, they call lambda. Or trough to trough, one wave. This is considered one wave. Okay, the distance measure centimeter, nanometer, micrometer, depends, okay, on what kind of wave we're talking about. And another way to look at it would be it comprises of 4 quadrants. You see, area under of it is 1, 2, 3, 4. For this case, you have 1, 2, 3, 4. 4 of a quarter make a wave. You have 4 of a quarter make a wave. So measure the distance from there is called lambda. Okay. At the same time, is also, let's say for example, easier to see. I'm going to start out with here. Time is 0, go up, down to here. So this is also one wave, the highlighted path. Okay. The time from the wave to start to end is called period. Okay. There are terms. I try to keep it short. Symbol is T. Okay. Period is actually the time required to make one wave. Time for one wave. Time to get one wave. How long does it take to make one wave? Okay, to make it simple in layman term. Alright, so that is most of it. You need to learn the basic fundamental, because once you know this, what happened is you have a new term that you have learned in since Form 4, Chapter 1, called frequency. Frequency, symbol small f, is defined, you remember it last time, right? It's 1 over period. But what does it mean? Okay, there's no meaning last time. It's 1 over time, isn't it, in terms of unit. Here in Physics Form 5, you learn frequency. What is frequency? Frequency is actually, I'm going to put a symbol, it's called number of wave. Get used to this now. This is called number, okay? H key is number. I don't want to spell it out because it's so long, so I'm going to use a symbol, number of wave over the period of time. So the period is not actually true, but it's a matter of time. Okay, because if you were to memorize your previous way of learning physics is frequency is 1 over t, then you have problem understanding the question or answering question here. Now in Form 5, the unit would be the same, just like what we have learned last time. Frequency unit is hertz. It's the same thing, it's just that you're going to get it more accurate. Or we put it the other way, number of wave per unit time, or number of oscillation. Number of oscillation by the system, by the vibrating system in a second, in 1 second. A standard answer perhaps. Now, what does it mean? How does it look? How are you going to solve a question like this? Okay, now let's refer to this wave. Say for example, this is 0, a wave starts, it doesn't end here, but instead, now, say I started off from here, up, down, and then here, question like this, it ends here. This is definitely not one wave. And they let you know, question like for example, this is one example, the time from here to here, it says, let's say 2 seconds. 2 measure unit in second. Let's say in 2 seconds. From here to here is 2 seconds. What's the frequency? Because now it's no longer one wave. So you can't solve this question if you memorize what you have learned last time. So how do you do that? Well, frequency F, example on above, how to calculate F is number of waves per time. So how many waves are there? Now, from here to here, they are 1 quarter, 2 quarter, 3 quarter, 4 quarter, 5 quarter. Obviously, they are 5 of a quarter wave. 5 because they are 5 quarter. 1, 2, 3, 4, 5. 5 quarters. I'm going to label it 1, 2, 3, 4, 5. There are 5 quarters. Over how long? Period is 2 seconds. 2 seconds. Number without unit, meaningless, so put a unit. So therefore, you calculate, therefore the answer frequency would be like what? 5 over 4, so it's how do you do that? 5, 8, right? So it's 205. This is 508. So this 5 over 8 hertz. Okay? Right? So this is how you want to make use of this equation. You calculate how many quarters are there in between time given. Alright? So how you learn, this is how you learn about frequency. Look at how many quarters are there. The best way, this is the best way I'm going to show you. How many quarters are there over period of how long? 2 seconds. It's second, yeah? Be sure it's second, but not microsecond, because otherwise you need to convert it to microsecond, convert it to second. Okay? Because next here, oh, yeah, okay. This is a top view. What I've shown in the previous picture, this is a profile side view, okay? This is the top view, oscillate up and down. It pull this paper, and then this is the trace of the wave. Now, if it were to be on a water droplets, drop water on it, then what you get here is actually, to here is actually the crest. Okay, the distance of piece of paper, distance here to here, is called lambda wavelength. Okay, and the trot, this is the trot, down, down to down. This one here is also lambda. You will measure in that way, yeah, trot. To trot. Okay, it's a piece of paper. I fold them into a fan and then open it up. You get this trace line. Okay, this is the crest to crest, trot to trot. You measure this distance. This is the wavelength. Okay, this is a top view of. I'm going to show you what's the top view. Right. So next would be, what's the relationship? How to relate them? Frequency alone is nothing much. You may pause this video. This is something good about video. You may pause it and then relationship between the velocity, the frequency, and its wavelength. Okay. I think I'm going to pause this video. And the next video, I'm going to focus on the relationship. While you still have time to read on your reference textbook on the previous introduction. And you may also try chapter by chapter questions, about 10 questions, 8 to 10 questions, on how to calculate the frequency, how to determine what's the period of time. Because Otherwise, it defies the purpose of this video. It's not meant for you to go through everything and then you thought you know how to do it. Practice makes perfect. Pause this video, go through the chapters, go through the chapter by chapter exercise book, and get about 10 questions. It should be more than sufficient. Look for frequency, look for period, and yeah, come back to my next video. Press on thumbs up on my YouTube channel because I like it a lot, and subscribe to my channel if you haven't already done so. Stay tuned to my next video.